Okay, let's walk through the calculations for experiment 9.2, the penny lab, where we dissolve the zinc out of the inside of the penny. I'm going to use numbers that are not correct here, that are a little bit off from the numbers you should have. I'm going to use a penny that is 3.55 grams, and copper, what was left of the penny afterwards, is 0.21 grams. Now, with each of your pennies, you should be able to do this calculation. The first calculation of calculate the mass of the zinc in the penny that was reacted. That's pretty easy. The mass of the zinc is equal to the penny mass minus the copper's mass. So in this case, the mass of the zinc is equal to 3.55 grams minus 0.21 grams, which in this case would come out to 3.34 grams. You can do this for each of your 3 pennies, and you should do this for each of your 3 pennies. The next question on the lab is, knowing the total mass of the penny and the mass of both copper and zinc in the penny, calculate your percent composition. Now remember, percent composition will be the mass of either copper or zinc divided by the mass of the full penny. So for our percent copper in this case, we'll take that 0.21 grams I had and divide by the total mass of my penny, 3.55. For my percent zinc, I'll take the zinc I just found, 3.34 grams, and divide by the 3.55 grams. This one will come out to 5.92%, and we're multiplying each of these by 100 to make them a percentage. So this should have a times 100 in it, and this one will come out to 94.1%. You can do this for each of your 3 pennies. Pretty straightforward. Now the third question, according to the U.S. Mint, pennies are 97.5% zinc and 2.5% copper. Calculate the percent error for your experimental percent composition zinc. So we want to look at zinc. Percent error is equal to the absolute value of the experimental value minus the theoretical value divided by the theoretical value, and the whole thing times 100. Now your experimental value will be the percentage you just solved for, which in this case is 94.1%. The theoretical value is the 97.5%, which was given to us in this problem. So that's the value it should have been, 97.5%, and the whole thing times 100. So when I subtract 94.1 minus 97.5, I get negative 3.4, but this is an absolute value. So in this case, my percent error is going to be 3.4 divided by 97.5 times 100, which in this case will be equal to 3.46%. And you can do this for each of your 3 pennies. And the next question, using the accepted density of zinc, the accepted volume of a penny, calculate the mass of the penny if it were made of solid zinc. So now we're going to look at density. Remember, density is mass divided by volume. We're trying to solve for mass, so mass is going to be density times volume. Multiply both sides by volume. So in this case, our density is 7.140. Our volume is 0.360. So 7.140 times 0.360, we get 2.57 grams. So we're saying if the penny was all zinc, it would be 2.57 grams. Now, for this next one, if we were to trap the hydrogen gas that was made in the reaction, use the mass of zinc from calculation 1 and the moles of HCl from pre-lab number 3 to calculate these answers. Which is the limiting reactant and how much mass of hydrogen would be produced. Now our reaction here, anytime we have a limiting reactant problem, we write the balanced equation. Zinc plus hydrochloric acid, single replacement, forms zinc chloride. Zinc is a +2. And hydrogen gas, which is diatomic. So it's Zn plus 2HCl forms ZnCl2 and H2. So take the zinc from one of your pennies. You only need to do this for one penny. So in my case, my 3.34 grams of zinc. Yours will obviously be a different number. I'm going to go to moles of zinc. Zinc has a molar mass of 65.38 grams. Go from moles of zinc. Since I want to find hydrogen in the end, I'm going to go to hydrogen. So 1 mole hydrogen for every 1 mole zinc. And then 2.02 grams of hydrogen for every 1 mole hydrogen. When I do that, I get 0.103 grams hydrogen. Now I also need to use the HCl. If you remember in the pre-lab, it talked about doing this calculation. You had 150 milliliters of 3 molarity HCl. So 150 milliliters, 0.150 liters times 3 molarity will give us the number of moles, which in this case is 0.45 moles HCl. You can go from that to moles of hydrogen. 1 mole hydrogen for every 2 moles HCl. And then from that, we can convert to grams of H2, 2.02 grams H2 for every 1 mole H2. When we do this, we get 0.455 grams H2. So we know in this case, based on this calculation, zinc is limiting and 0.103 grams of hydrogen are produced. So those are the answers to those first 2 questions. Next, how many moles of hydrogen are left after the reaction, and what is the molarity of this solution? So, to find the grams of hydrogen, we need to start with the zinc. So I'll use my number. Once again, you'll use your number. And I need to convert to moles of HCl. So I have 1 mole zinc for every 65.38 grams. And then 2 moles HCl for every 1 mole of zinc. That comes out to 0.102 moles HCl. Now from the previous page, you remember we started with 0.45 moles of HCl, what we calculated right here. So the amount left over would be 0.45 minus 0.102, which means I will have 0.348 moles HCl left. And then I want to find the molarity of that. So it was in 150 milliliters. So molarity equals moles over liters. So the molarity here is 0.348 divided by the liters, 0.150, which comes out to 2.32 molarity. Obviously, yours will be a different answer than that, but that's the method you would go to. These last two questions are explanation questions that you should write a short answer for. Why is the master penny so close to the hypothetical solid zinc penny? For this one, I would pay attention to the mass of copper versus the mass of the penny, and think about why a solid zinc penny would not be very different from the regular penny, or the percentage zinc versus the mass of a penny. Another way to think about it. What percent is zinc already versus how would it be if it was pure zinc? The other one, copper and zinc are next to each other on the periodic table. How is it possible one of them will react with hydrochloric acid but not the other? For this one, pay attention to the metal activity series. Higher on that list replaces lower. Look at the placement of hydrogen, zinc, and copper on that list. Higher will replace lower, but lower cannot replace higher on that list. And that list can be found in your formula chart that I emailed to you, that I put on Moodle, and that many of you still have a copy of one of those colored sheets. If you have any other questions about this lab, please email me to ask those questions.